In October of 2012, Dr. Brent Yorgey posted his creation of factorization diagrams. I want to use this idea of these diagrams to engage my sixth graders in knowing their math facts. They are simply not learning them. I played with the diagrams and created a multiplication table. I later discovered that Dr. Yorgey had generated a multiplication table using his program. This slide compares the two tables, mine on the right and Dr. Yorgey's on the left. For my sixth graders to learn their math facts and develop a sense of numbers, I wanted to highlight the commutative property, paying attention to the groups and the number of dots within each group. One approach is to create diagrams that students use to work through the prime factorization, or combination of factors. Here are several examples. The factor pairs of 24, prime factorizations of 24, prime factorizations of 50. This is where I started to see some interesting designs based on how I rotated the subunits. Here's a prime factorization of 50 that shows the two groups of 25 reflected. Here's the same prime factorization, with the subunit on the right rotated 144 degrees counterclockwise. This rotation results in a reflection of the pink subunit. So these diagrams become interesting, fun to create, fun to work through the factorizations, and I hope engaging for my sixth graders. Here's a different combination of prime factors that equal 50. I have to look for a while to see the five groups of two groups of 5. This is two combinations of 60. The 5, 2, 3, 2 version on the left is a mess. I was trying to make a more interesting design that did not turn out well. However, I was able to clean up the mess with a simple translation. So how do I go from here to here? Here the figures are side by side. I'll come back to this later. The last example are two drawings of a prime factorization of 60, 2, 2, 3, 5. The figure on the left is a third way to make these factorization diagrams. The first was based on Dr. Yorgey's diagrams. The second is these dot diagrams I've been showing. And the third, and this is the third, I'm not going to do much with these right now. The design of these diagrams is endless and provides opportunities for my sixth graders to be engaged and challenged while learning math. My goal is to get some software in their hands that they can use to create their own diagrams. I use CorelDRAW to work through making these diagrams. My students do not have access to CorelDRAW, but they all have the app Doceri on their iPads. First, my use of CorelDRAW to make the 24 as the product of 8 groups of 3 dots per group. To make these diagrams, I created a set of polygon dots, 3 through 12, plus dots for 1 and 2. No polygon for these. I decided to call these diagrams factorization dot-agons. Here's the octagon for the 8 groups. Copy and paste both the octagon and the triangle and 3 in each group. CorelDRAW is great because of the copying, rotating, sizing, etc. Add a little color and you get a nice design for this simple factor pair. Again, my goal is for my students to make these diagrams, not just analyze drawings that I provide. For this, students will use Doceri. Of course, I discovered an interesting problem as I did the prime factorization of 50, the 552 factorization. Here it is. Begin with the 5 groups of 2, of which I will then have to make 5 groups of these 5 groups of 2. I got mixed up and ended up with 30, 6 groups of 5. But at the same time, I discovered that I could not select all the images to manipulate. Selecting all the images and resizing as a group is done often while making these diagrams. I cannot select multiple images imported into Doceri, but I can select multiple drawings that I create in Doceri. So the fix is for the kids to use the templates to make their own drawings, something they already know how to do. This is in Doceri. Once finished with the drawing, the image template can be deleted and the drawing can be manipulated. Copy, paste, rotate by hand, and there it is, 5 groups of 5 groups of 2 equals 50. Back to 24 as 8 groups of 3. The sizing is a little hard to control. Hey, you know the app is free. Here are some factorizations of 50. I want to spend some time on the 255 version that I showed previously. This is in CorelDRAW, which educators can purchase for about $110. This is useful to make videos to show students even though they don't have access to the program themselves. So copy, paste, rotate. There are the 5 groups of 5. Now I need 2 of these units. I need 2. So grab the template for 2. Add some color. Copy, paste, and translate. Add a rotation for discussion. I think that's a nice design. Imagine having kids follow the cursor around the diagram and writing a script for the video. The last factorization I will describe is the 5223 factorization of 60. This is the diagram that I messed up earlier. I wanted to compare the 5232 diagram to this one, 2235. These steps show the usefulness of CorelDRAW. So I got here and tried to make a nicer design. Oops, it is not as bad as I thought at first, but I still wanted a cleaner version. Here is the first design next to the clean design. I treated the 2 groups of 3 groups of 2, 12, as subunits. Slid them away from the center, then slid each subunit vertically through the center to the opposite vertex of the pentagon. I love this language for my 6th graders. And there it is. While some of this might seem simple for adults, I assure you that none of it is simple for my kids. Thank you.